Okay, so got the blue ball moving totally horizontal, so it's only got an x component in the positive x direction to its momentum. So it will be mass 2 times velocity 2, 3 times 8, 8, 16, 24. It's got a 24 kilogram meter per second velocity, momentum vector going to the right. We've got to take the red one and break that apart into how much of that momentum before the collision is on the x-axis and how much of that momentum before the collision is on the y-axis. So this is going to be MV 20 sine 50, and I wrote that down somewhere. That comes out to 16.78. And this one's going to be the entire momentum 20 cosine 50, which comes out to 12.85. So right now we have all the information that before the collision in a numerical value. The total momentum before in the x dimension is going to be 16.78 plus 24. So that's going to add up to be the total momentum this way before, which would be 24 and 16 is 40, 40.78 kilogram meters per second. Whatever I have afterwards better add up to that. And I got a total momentum in the y before. Since the blue one has no component in the y, it's just due to the red one, 12.85. So I better have that amount afterwards. I'm going to break this guy apart into how much of this functions on my x-axis and how much of it, arrow going that way, positive x, and how much of this functions in my y-axis. This was down, so I'm going to give this a negative number. This says up is positive, so I don't lose track of what's what. I got to take care of all of our signs right away. So this one's going to be MVE, which would be, it's the same ball, same mass, 3 times 9. That would be the total momentum would be 27 kilogram meters per second. This would be 27 cos 35. That comes out to 22.12. And this one would be 27 sine 35, and that comes out to 15.48. Oh, this is going to be a lot easier than I thought it was. Okay. I have to have this much in my x dimension. This red one afterwards has an x component to its momentum and a y component to its momentum. So all I've got to do is compare. Let's see. We've got 24 plus 16.78 giving us 40.78 total before in the x. That has to equal 22.12, which is the x component of the blue guy, plus the momentum of the red guy. We'll just say P sub A, P after, and I'm given, this is my angle, it would be P after cos theta. And in my y dimension, we've got down in the negative, we've got negative, oh, should be red, right? Negative 12.85. That's the total momentum before in the y dimension, has to be equal to the total momentum afterwards. That's going to equal this component, which would be down negative 15.48 kilogram meters per second, just leaving the units out. And this one is going to be the y component plus the momentum after in the y, which would be the sine component. So let me do a little bit of arithmetic. If we add this to both sides, you get what? Didn't bring my calculator home. So that would be 3. This would be 6, 4, 2. Positive 2.63 equals, I'm just going to stick with blue for now, PA sine theta. Now I'm going to go over here, my x dimension. You've got, that's my y stuff. That equals that component plus PA cos theta. So let's move this over. All our signs are correct. Subtract 22.12 from that. What do we get? 6, 6, 18. So I'm just going to move this over to here. 18.66 equals P A cos theta. So which one do we want to solve for? Sine over cos is tan, so let's do that. PA equals 18.66 over cos theta. Just dividing both sides by cos theta. Then I'm going to take this, plug it in there, and I get everything in terms of theta. I get 2.63 equals 18.66. Sine over cos theta gives me tan theta. This is a point where I could solve for theta. So you've got 2.63 divided by 18.66. Take the arctan of that. Gives me theta. Oop, I'm out of my picture. Now, let's see if I can do this on my phone. Okay, we got. I don't know if I could do this on my phone. I think I have arctan on my phone. Well, whatever that comes out to, you can find theta. At that point in time, you can take theta, plug it in to any of these equalities, and solve for the momentum in the A. Once you got the momentum in the A, obviously the momentum of ball A, you can solve for the V after. That's it.